Today's video, we're going to look at just examples on taking higher order derivatives. First, consider the function f of x equals x to the fifth minus 3x to the fourth plus 4x cubed minus 2x squared plus x minus 8. Let's go and find all higher order derivatives. So first we need f prime of x. This would be 5x to the fourth minus 12x cubed plus 12x squared minus 4x plus 1. Let's take the second derivative, f double prime of x. Now this is the derivative of the first derivative. So it's the derivative of f prime. That would be 20x cubed minus 36x squared plus 24x minus 4. Let's take the third derivative, f triple prime of x. This is the derivative of the second derivative. So this will be 60x squared minus 72x plus 24. The fourth derivative, which is represented that way, is the derivative of the third derivative. So we get 120x minus 72. The fifth derivative of x is the derivative of the fourth derivative. That's just 120. Now notice that's a constant. So if we take the derivative of it, it'll be 0. 0 is still a constant, so derivatives of 0 are still 0. So we can say that the nth derivative of x will equal 0 for every n larger than 5. Alright, so the fifth derivative is 0, the sixth derivative is 0, the seventh derivative is 0, eighth derivative is 0, so on and so forth. Alright, now let's take a look at the function y equals 2x squared plus 3 to the 3 halves. And we want to find the second derivative here. So first derivative is a power rule, so 3 halves, 2x squared plus 3 to the 1 half. And chain rule, multiplied by 4x. We're left with 6x times 2x squared plus 3 to the 1 half power. Now we want to find y double prime. And remember, that is the derivative of what we just found. Now we have a product rule. First, times the derivative of the second, 1 half, 2x squared plus 3 to the minus half. Then chain rule says multiply by the derivative of 2x squared plus 3, plus that second function times the derivative of the first. Simplifying, let's see, we'll get 12x squared over the square root 2x squared plus 3, and plus 6 times the square root of 2x squared plus 3. On the denominator, we'll get 12x squared plus 6 times the quantity 2x squared plus 3. In the numerator, we have 24x squared plus 18 all over the square root of 2x squared plus 3. And if you wanted to, you could factor out a 6 in the numerator and write 4x squared plus 3 all over square root 2x squared plus 3. And that would be our second derivative. So that concludes the video on higher order derivatives. Said very short video, just looking at a couple examples on how to do them. No need to spend too much time on them since it's just taking derivatives, which we've spent several videos doing already. In the next video, we'll also just be looking at examples. But this time we'll be looking at how to find slope, or dy dx, of a function that is implicitly defined.